Alright, so now we're almost at the finish line of this application. We created a model for our to-do. We created our repository, which will communicate with our Postgres container. We handled the service, which will handle all the middleman logic of validating information and structuring it in a way that it will be able to communicate with the repository and leverage the repository to return a response. And now we have to create the controller, because that is essentially our entryway into the application, right? So when we make a request, we want to be able to receive that request, send that request to the service and the repository to be able to do the logic that is expected, and then send a response back to the user. So let's get started on the controller. Alright, so now it's time to create the controller layer for this application. The controller layer is what we're going to use to receive requests from the client and send responses back to the client. So let's actually create this controller. Let's right click on the controller package, create a new Kotlin class, and we're going to call it to-do controller. So now we have a class called to-do controller, but how do we let SpringBoot know that this is going to be a REST controller? Well, luckily we have an annotation called REST controller. So let's use it. So we're going to import REST controller, and what this does is it creates a RESTful web service within Spring. So what this REST controller does is it takes care of mapping requests and its data to the specific request handler methods that we're going to generate for this to-do controller. And once that logic is done based on the requests, this is also going to handle sending a response back to the client. So we're going to go over these request handlers methods later on, but and we're going to create them obviously, but this is what the REST controller does. It pretty much lets SpringBoot know that this is going to be our REST controller, and is going to be able to take in those requests and also send a response in a JSON format. Now, a second annotation that we're going to need is the request mapping. Let's use that at request mapping. And what this request mapping annotation does, it's used to map web requests to our specific handlers in this class. So we can specify the endpoint name using this request mapping, and if a client reaches out to that specific endpoint, is going to handle that within this class based on the specific handlers that we're about to create. So if it's like a get, if it's a put, and we're gonna define some methods to handle specific HTTP methods, but if it matches that endpoint initially, then it's gonna direct it to this controller. Now we can define like the initial endpoint by opening up some parentheses, open up some quote, and then we can define how the endpoint is gonna look like initially. So say for instance we wanted to do v1 API. Whenever the user uses the URL and add a v1 or /v1/API at the end, is going to direct it to this controller, and we're going to create some methods to be able to handle those requests that come in that matches this endpoint, right? So since we're running this locally, it's going to be localhost.com. And if the user uses /v1/API, then it's going to direct that request to this controller. And now, because that request is being directed to this controller, we have to be able to handle that request. And that's why these method handlers will become very useful in those use cases when those requests direct to this controller. So let's create a method handler for specific request. But first, let's do what we did similar to the to-do service. Remember, in the to-do service, we auto-wired a instance of the to-do repository because we knew that in the service we were going to interact, or we needed the repository to communicate with the database. So in the controller, we're going to need an instance of this service so that we can send the request that is coming into the service, and it can handle the logic of communicating with the database and then returning that data back to the controller, which would then allow the controller to send a response back to the user. So it's a linear process, but then it's going to come back to the initial point with some data. So we're going to have to auto-wire the service in the controller, just like we did with the repository in this service. And this is possibly because we use the service annotation And remember, like I said, by default, a service annotation is also a component. And when SpringBoot starts up, it scans for components. It creates an instance of each component that it scans for. And this will allow us to inject that instance into whatever needs it by using AutoWired. So let's do that. Let's create a late init var, and we're going to call this to-do service. And then that's going to be an instance of to-do service, and then we're going to use the annotation AutoWired. And now we should be able to use some of the methods in the to-do service to be able to send our logic to do what needs to be done. So let's start creating these method handlers so we can, leverage some of these methods within the to-do service. So the first thing that we created in the to-do service is to allow users to be able to save a to-do, right? So now I want to be able to create a method handler that will handle when a user sends a post request to this endpoint, right? So they send a post request to v1/API. I want to be able to create a Postgres to save that information to the database because they're sending a post request with a to-do information. So to do that, we're going to use a thing called @post mapping, which essentially just says that if we receive a post request with a specific that matches a specific endpoint that we define, then we're going to essentially take that request and run some logic based on the function that we define. So let's see this in action. So we're going to create a function called save to do, and we're going to accept a request body, right? So to accept a request body, we're going to use an annotation called @request body, right? So that's essentially going to take in a request body that the user sent, and then we're going to try to map that request body to to-do entity, because we're expecting the user to send it in a structure that we expect. If it doesn't, then that's going to be a problem. But if it is in a proper format, then we're good to go. Open that up. All right, so one more dependency that we're going to need is the validation dependency. So let me open up this pom.xml, and I'm going to put this as close to the bottom as I can and paste it in. Let me make it a little bit bigger. And paste in the dependency that we're going to need for validation. It's going to be called SpringBoot-starter-validation. And what this is going to do is going to allow us to leverage a annotation called valid, which will make sure that the request body that we're receiving is a valid request body. So let's go back to the to-do structure or controller. Zoom that in a little bit, and I'm going to use an annotation called, or actually I forgot to make sure that Maven accept those changes and actually start downloading the dependency. And then you can see at the bottom right that it's actually downloading the dependency. And then if we go back to the controller, we can use the annotation called @valid. And let me close that up. So @valid, and then let me just import that. And that's going to make sure that this request body is a valid structure for that matches the to-do. So now we can start leveraging this to-do service to be able to save the to-do that we just received. Now to do that is not hard at all. It's just we're going to return whatever the to-do service does after we leverage the method of save to do, and we're going to pass in that to do, and we're going to make sure that we return that to do back to the user with the ID and all the information that was generated after it was saved into the database. Because remember, in the to do service, if we go there really quick, go back to the to do service, we saw that if we save a to do structure, after it saves that information, it's going to return a to do, and that's the to do that we just saved. So we're going to return that. So when we use it in the controller, it's just going to simply be the to do that we just saved inside of the database. So as you guys can see, that communication is important. We're going to use the service, or the controller is going to communicate with the service is going to communicate with the repository, and everything funnels right back to the initial point. And then we're going to use an annotation called @post mapping. This makes sure that it's going to funnel, or we're going to make sure that when we receive a request at this endpoint, right, it has to be v1-API, and we make a post call, it's going to go to this save to do. Now we can also append on another piece to this endpoint, because I want to make it more specific. So I'm going to open this up, and then I'm going to open up some parentheses or some quotations and define an additional piece to the endpoint. So I'm going to do slash to do, and I got to remove the slash at the end here. It's going to be double. So it's going to be slash v1 slash API slash to do. So whenever somebody make a post request to that, then it's going to run this save to do a method. So cool. That is how we handle post request in our REST API. Let's now do a get request, because whenever we save information, maybe we want to get everything that we saved in totality. So let's do that. Let's create another function called all to do. Open that up, and we're not gonna take in anything. We want to retrieve everything, so there really isn't anything that we should expect. They just want everything from the database, which we'll give to them, and then we're gonna make sure that it's gonna return a list, and that's gonna be of type to do. And then we're gonna open up the curly braces, and we're also going to use another type of mapping, because like I said, this is going to be when a user makes a get request to retrieve all of the to-dos from the database. So we're going to use a annotation called get mapping. And as you guys can see, if you know a little bit about HTTP methods, which if you don't, then I'll leave a link in the I'll leave a link somewhere on the screen to my HTTP video that describes different methods and what they're used for. But as you guys can see, it matches the name of each HTTP method. So you're gonna have post, you're gonna have get. Eventually, we're gonna do deletes, but you can see the pattern of how that can be used. So we're gonna do a get mapping, and in this case, we just want to get all of the to-dos. So we'll just make sure that whenever somebody does a get, using v1 slash API slash to do, then it's going to return all the to-dos in the database. And to do that, we're going to also leverage the service, which we can just do return, and we're going to do to do service, and we're going to retrieve all of the to-dos. And let me see what this says. Oh yeah, because it can be nullable, we're going to have to put a little question mark at the end. Cool. Now, the next one we're going to do is, what if they want to update to do, right? So this is going to be a little bit more, right? Because first we have to take in ID of the to do that they want to update, and we also still got to take in the structure of the to do. So we're going to create another function, and then we're going to do update to do. We're going to call it to update to do. We're going to open this up, and I'll make it on another line because we're going to need two parameters. The first parameter is going to be a let me actually create the annotation for put mapping, because it's going to make more sense as I define the parameter. So like I said, with updates we use put, so there's a thing called put mapping, and we're going to open that up and define how the endpoint is going to look like. So we're going to do to do slash, and we're going to take in the ID as a parameter or a path variable, right? So to do that, to specify that a user is going to send an ID after this slash, we're going to open up some curly braces and give it the name, right, of what we should expect. And we're going to define what this ID type is going to be, and we're going to retrieve it and give it a variable name. But this is just letting SpringBoot know that we expect a value to be sent within this endpoint URL, and it's going to be an ID in our case. So how do we retrieve that value? We're going to use an annotation called path variable, and we can specify that the path variable that we're going to attempt to take in is ID, right? So this is the same name, right? And we're going to take that path variable called ID, and we're going to store it into a to do ID variable, and it's going to be of type long, because remember we defined our IDs to be long. So this path variable that this is being sent through here has to be a long. So that is the first parameter, and the second parameter is that we got to make sure that we retrieve a valid request body. So that is what we're going to do. We're going to use the valid annotation like we did above, and we're going to make sure that it is a valid request body, and then we're going to store that in a to-do variable that's going to match the same structure as the to-do entity. Cool. And then let's open these curly braces up and start defining some logic for that. So really all we got to do is return, and we're going to leverage the to-do service again. So easy, right? Because it keeps it clean. Like, we don't have to have any of the logic in here. Like, yes, you got to make sure that the request is, a valid structure, that it can be mapped to this to-do structure, and that, okay, you might need to get some information from the path or from the from specific places as the request comes in. But the logic that handles the validation and how it's going to be structured and how it's going to communicate to the repository should just be within the service. It shouldn't be in the controller. It just makes everything look so much cleaner. So let's actually, like I said, leverage the update to do to pass in first the to-do structure and the ID. And then that should return a to-do. So we should define that it's going to return the updated to-do. So we can do that right there. And now we should be good to go. So now it's going to take that to-do, the to-do ID. It's going to update it in the database. And then it's going to return the updated to-do back to us. And we're going to send that back as a response. Then the user can update their UI or whatever they're going to use using that updated to-do. So cool. And the last thing we're going to use is the delete mapping, right? So we're going to create a function called delete to do by ID. Or actually, I'm just going to do delete to do. Actually, not to delete to do by ID. That's fine. And then we're going to open up these parentheses, and then we're going to define pretty much the same thing as above. I'm just going to copy and paste this actually, because what we expect is we just need this line, the path variable, because I'm just going to delete it by ID. I don't need the actual request body. So I'm just going to take in the path variable, and I'm going to define that right now by using the annotation of @delete mapping. And then I'm going to open that up. I'm going to do a slash to do, and then slash, and then I'm going to open up some curly braces and use ID. The path variable here is going to take the ID and then pass it into this to do ID variable. And then I am going to open that up. And then now I am going to do service dot delete to do by ID. And then I'm going to use the to do ID that we just retrieved from the path or from the path variable that we just retrieved. And then I remember we made the to do service a string, but let me confirm. So the delete to do by ID was a string, so we can do that. We can just return that to the user, but we just got to define that this is going to be a string, so we can do that. So cool. Now whenever the user deletes something, it's going to get a response of deleted. They can use that to make sure that it actually went through, because by default delete to do by ID in the repo is a void type, but just to make sure that it actually sends something back to the user so they can do something, we're going to return the string of deleted and call it a day. And we're going to structure that a little bit more in the next piece of the video. We'll send a proper response, a more proper response in a better structure. But for now, this is how we create our controller. We define that it is a REST controller. We create a request mapping so that we can structure the endpoint. And if the person hits the specific endpoints, then it will look into our method handlers and see how that is structured, and if it matches any of these method handlers, then we're going to run the logic. And our logic is internal of our to-do service, and the to-do service will handle the communication within the with the database using the to-do repo or using a repository. And we can even retrieve variables from our URL if they pass in something within the URL. So in this case, we could retrieve an ID by using a path variable annotation, and we can make sure that the request is in a valid structure by using the valid annotation, and that it is that is structured into a request body by using the annotation request body. And we can make sure that we're able to retrieve different or retrieve requests by different HTTP methods by using different mappings. So we can use post mapping, get mapping, put mapping, and delete mapping. So that is some cool stuff. And now we have our controller. And now let's see if it actually works by using Postman. All right, so now it's time to test if everything actually works, right? So one thing I can say is you can remove this line. I know initially I said that this is optional. So you can remove this line, and now we can actually run this application to see if it's working. So let's go into the to-do application.kt or wherever you named it. So if you open up your package, it should be the file that's outside of all the other folder structures. But in my case, I named it to-do application, so it's going to be called to-do application.kt. And if you're using IntelliJ, you should see this play button. So you can press that, and we can start running this application and seeing if it actually works, right? And if it doesn't, then we're going to have to do some debugging. But it seemed like we are good to go. So let's open up Postman and let's see our controller in action. All right, so now I'm using Postman to test our API. This will allow us to create different API requests and leveraging different methods to a URL that we specify. And this will allow us to put in some JSON and test out different endpoints that we defined in our application. So as you can see here, I already defined the JSON that we're going to use. And to do that, all you had to do was first pick that it's going to be raw, specify using this dropdown that is going to be JSON, and then we could write out the formats of the request. So in this case, for our application, we only need title, description, and progress. So for the title, I'm actually just gonna put first. Actually, no, I'm gonna put demo, and then I'm gonna put in first entry for the description. And for progress, we're gonna set that to false initially. And I have to change the port to 8001 because I changed that port number in the applications.properties file when I first started this application. So now that everything is defined, we defined our body, we defined the URL, we defined the HTTP method. Now we can just send it. And actually, let me pull this up. Oh, see? So this is the first time that I've seen that an error might be a good thing. But remember what I said with the request mapping. If it doesn't matches the exact structure of the one that we defined, the SpringBoot's application is not going to know what to do with it, right? We don't have anything with /API/to-do, right? We have v1/API/to-do. So we're going to have to put that in and then send it, and then boom, right? So we saved it and we see the new entry. We see the ID that was generated by SpringBoot. We see the title, description, and progress that we sent. And we see the created at and updated at timestamp of when this was created. So that is a success. We created our controller. And now we can start playing around with the other method handlers that we created, or the other endpoints that we created. So next, let's do update. And let me just copy this because we're going to use that a lot, this URL a lot. So let's go into update. And as you guys can see, I already have a body here. It saves a lot of time. So we're going to change progress to true. We're going to actually make this description updated. And we're going to specify the ID here. And then we should be good to go. So remember, like I had in the application, that to update is going to take in the ID that we pass in the URL, and it's going to search for that ID and make the update based on what we sent in this entity. So let's send that over using the put, and then boom, we can see that the ID is still one, the title is going to be first still, the description is now going to be updated, and the progress is now true, which is the opposite of what we had before, which is false. And if you looked here, created at timestamp is the same. If we go back to add, you see it's 18/25/574. So you'll see the same thing here, but the updated ad is different now because we just updated it. So it's gonna look, or it's gonna be different, right? Because every single time we update something, we created an, or we use the annotation of updated timestamp to make sure that whenever we make an update, that updates the timestamp. So it is looking good. All right. So now we can try to leverage the get to do. And let's update this URL. And now we can just get, we don't have to specify a body. We're just going to retrieve everything from the database. So we just have to specify that we're trying to retrieve all the to-dos. So if we just send this over, we only have one thing in the database. So it's just going to retrieve a list of just one to do. Let me add something again. And I'm just going to call this second entry. And I'm going to save that. And boom, it's going to return an ID of 2. Like I said, it's going to generate a new ID because we used a annotation called generated value for the ID. So it's just going to increment by 1. And this is our second entry. So if we go back to get and we do the get again, now we see multiple entries. We see the first entry, or in this case, it's going to be updated because we updated it. But then we're going to see a second entry. Cool. And now we have the final one that we created. The final method that we created is going to be the delete to do. And let me just also paste in the previous URL. And I'm going to add in the ID of what we want to delete. And in this case, I'm going to use 2, right? I want to delete the most recent thing that we created. And I'm going to use the delete method. And we don't even have to send anything else. We just got to send the ID through the URL. And now we'll be able to delete what we have to delete. So let me just send that. And boom. Like I said, we're just going to get a string that says deleted if it actually went through. And that's what we got. But yeah, that's how you delete. So if I go and try to get again, boom, now we only see the first entry. And I can go back into delete. I can use 1. I can send that over. It's deleted. Go back to get. Send that request to get everything in the database, and it is empty now. It is an empty list. So everything is working as expected. In a perfect universe, obviously things happen, and things break. So in the next portion, we're going to go over how to handle those times where things can break using exceptions, right? We want to make sure that it's formatted cleanly when everything breaks. We don't want to scare the clients or whoever's using our application. We want to make sure that they actually understand what is going on. So we're going to create some exceptions, but we're able to make the controllers. We're able to get everything running. So now we just have one thing left, which is making sure that everything is handled properly.